Okay, so Unit 4, Day 8, the discriminant. And it sounds a lot like discriminate, and that's kind of what we're doing, because when you discriminate, you judge by how something looks without really getting to know it or searching in detail. And that's what we're going to do today to these equations. We're going to make a quick judgment about this equation and about what types of solutions it has without actually finding the solutions. I should say before we find the solutions. So typically, the last couple of days when we did the quadratic formula, first off, the quadratic formula itself, negative b plus or minus the square root of b squared minus 4ac all over 2a. You probably got used to seeing some of the same answers over and over. Most of the time you either have two solutions, and sometimes you only have one solution. Now when you have one solution, it was basically the same solution twice. And so that one solution was a real number, and in fact it was a rational number too. Rational meaning it can be written as a fraction. Like 1/2 is rational, or 3/2 is rational. If there was two solutions, it was either you could have two rational solutions. They were both rational solutions, so two rational solutions. You could also have two irrational solutions, and those are the ones like 5 plus 2 radical 3. They're irrational. The decimals would be non-repeating but go on forever. And these are both made up of real solutions. It's just, in this case, they're both rational. In this case, they're both irrational, which, if they're rational, it basically means you could square root what was under the radical. So if you could square root that, like the square root of 144 is 12, you can add 12, subtract 12, they came out to be rational. If you couldn't square root that, then you have to get an irrational, because there'd be a square root in your answer. There were sometimes you get two solutions and they were two imaginary solutions. Okay, and that was if this had an I in it. So the big tell for that was if there was an I under the radical, you eventually had two imaginary solutions. Okay. The biggest thing though is everything I just said could be figured out by doing this part right here, what's under the radical. So we call that the discriminant, b squared minus 4ac. Once you did that, you could tell what kind of solutions you were going to get without actually getting them. So we were able to discriminate, to make a judgment about the solutions without actually getting to know the solutions or finding the solutions. Kind of a cheesy way of saying it, getting to know the solutions. So some of the different things that could happen here is if the discriminant is negative. Okay, so that means you have a negative under the radical. And here's an example. So if I took b squared minus 4ac, that'd be 2 squared minus 4 times a times c. Sorry, that should be a plus. Times c. And this would be 4 minus 16, or negative 12. So I could tell right now that what's under the radical is negative, so I'm going to have imaginary solutions. So if the discriminant is ever negative, you're going to have two imaginary solutions. What if the discriminant is 0? So here's an example. So b squared would be 12 squared minus 4 times a times c. Well, this is 144. And then 16 times 9 is 144. So I get 0, which means I'd have a 0 under here. Okay? So if you have a 0 under there, that means you're going to take, I'll just say in general, instead of specifically a, b, c here, I'll just say negative b plus or minus 0 over 2a. Well, if I'm adding 0 and subtracting 0, that's like not doing anything at all. So you're just going to have one solution, whatever negative b over 2a is. There's no plus minus. The plus minus is what made it two different solutions. Well, Here there's only one solution. So if your discriminant is 0, you have one solution. It is real, and it will be rational. So you have one real, and I'll put in parentheses, rational solution. So negative, imaginary, to imaginary. 0, 1 real rational solution. The discriminant is positive and a perfect square. So looking at this guy, so b squared would be negative 6 squared minus 4 times a times c. So this would be 36 minus 32, which is 4. So the discriminant is positive and it's a perfect square. What that means is I'd have negative b, again I'm just saying in general, I know that the b here is, would be 6 here, but plus or minus the square root of 4 over 2a. Well, square root of 4 is 2, so you're going to take a whole number, add 2 to it, and divide it by another integer. Then you're going to subtract, so a number minus 2. So you're going to get 2 real solutions, but there's no radicals involved because the radical cleared up, so they're going to be rational. So rational solutions. Okay, so 2 real rational solutions. And then what if the discriminant is positive, but it's not a perfect square? And what's going to happen there, I got b squared, so that'd be negative 4 squared minus 4 times a times c. So this would be 16 minus negative 24. That'd be a 40. Which all that means is when I would plug that into the general, I'd have the opposite of some number plus or minus the square root of 40 all over 2 times some number. Well, this here the radical doesn't go away. I could do some simplifying. I could take the 4 out of there, so it'd be the square root of 4 is 2, and I'd have a 10 left under the radical. But it doesn't go away. So I have they're still real numbers. They still exist. It's just irrational solutions. Okay? So I'll flip the paper over and do a few. Okay, so backside. Again, our goal, we just want to predict the type of solutions and how many there'll be. Well, there's going to be 1 or 2. They could be real or they could be imaginary. And then if they're real, they can be rational or irrational. So let's just quickly discriminate. Let's just look at it and make a quick judgment. So b squared, so it'd be 64 minus 4 times a times c. So it'd be 64 minus negative 144. So it'd be plus a positive, so 144 plus 64 is 208. So it's positive, meaning I'll have 2 real solutions. But since that's not a perfect square, they are going to be irrational. So irrational, which just means I'll have radicals left in my answer. Then I'm supposed to go ahead and solve it. So to finish up the negative b plus or minus, well, I've got negative b, so it'd be negative 8 plus or minus square root, which I've already found, b squared minus 4ac. I just put that in there, all over 2 times a, which is 2. So negative 8 plus or minus over 4. And 208 could split into, 16 and 13? And the square root of 16 is 4, so I'll put 4 radical 13. And I can do some reducing here, so divide everything by 4. It'd be negative 2 plus or minus radical 13 over 1, so I'll just leave it like that. So I got 2 real numbers, so they do exist, but they're irrational because they got a radical underneath them. Okay. It does say also decide if this would have been factorable. Well, if it's irrational, it means it's not factorable. Okay, so you don't have to worry about this one couldn't possibly be factored. The ones that are factorable are the ones that if it was 2 real but they were rational. If they're rational, which means they can be written as a fraction, it was factorable in the end. So that if you do the discriminant and you get 2 real rational, you may decide I'll try factoring instead. And maybe so let's try one of those here. So looking at this guy, I got 2x squared plus x minus 28 equals 0. Again, discriminant, so b squared would be 1 squared minus 4 times a times c. In this case, put that in the calculator, you get 225. Now, it's 225, it's positive, so 2 real solutions. So there's going to be 2 real solutions. But I can square root that. So if that's a perfect square, that means they're going to be rational. Meaning I could try to factor this if I wanted to. Write the 2 binomials if I chose to. I could do the quadratic formula if I wanted to. It's really up to me what route I take. So if I wanted to try to factor this guy, I know I've got to do 2 binomials. If that's 2x squared, this would have to be 2x and x. If that's a negative product, it's going to be plus minus or minus plus. And I'm going to do factors of 28. So 1 and 28, 2 and 14, 4 and 7. This is one where you just kind of guess and check a whole bunch of times. And maybe I'll switch to a pencil since I'm going to be guessing and checking. So if I plug a 4 and a 7 in here, outer plus inner, does that equal 1? So this would be a negative 14 plus 4. Nope, that's not 1. If I switch that this way, it'd be a positive 14 minus 4. That's still not it. So I could switch the order. I could do 7 and 4 instead. So 7 and 4. This would be negative 8 plus 1. Negative 8 plus 1 is negative 1. It's very close, so it must be 7 and 4. So 2x minus 7, x plus 4, so this would be outer would be 8, inner is negative 7, so that's the 1. So 2x minus 7 and x plus 4. So that means x would equal, and this one's the easier one, switch the sign, so it would be negative 4. This guy, switch the sign, divide by the coefficient, so 7 halves. So 7 halves and negative 4. If you go back and do the quadratic formula, you'll get 7 halves and negative 4 for an answer. So it's kind of up to you what route you want to take after that, but just know that it is factorable. The video is getting kind of long, so I'm going to cut it off here. You're about 12 minutes on the video, so I want to stop and give you a chance to work. Your assignment then is on Math Excel. So it's called Unit 4, Day 8, Day 8 Flex Day. It's all about the discriminant. I think you never have to solve it. We just figure out, like you'll stop right here and say 2 real irrational solutions, and that's your answer. So you don't have to actually solve it, but just make sure all that is done by Thursday morning. I believe at 8 o'clock is a cutoff. So you have to have at least 80% of this done, 80% correct by 8 o'clock Thursday morning to be considered complete. Otherwise, I have to turn in the office as you didn't do your e-learning. So I'll be available from 12 to 2:40. Again, after 2:40, I shut my computer, I go home, and I'm probably not going to check my email the rest of the day. So please get your emails in time for me to answer by 2:40. So have fun and enjoy.